Okay, so that's a compiler. It's a translation program from human level, high level machine language code into very low level machine language code of zeros and ones, in other words bit strings. So a compiler translates English-like text or program into machine level program, zeros and ones, into bit strings. Okay, all right. Now, so compilers they use something called tokens, and what are they? Well, like variable names. A variable like you know, it's some quantity that can take different values. Like in your program, you might say let x equal 2. Later, you might say let x equal 3. Or x would be a token. It would be something that can vary in its value. Okay, so of course such things like variable, and these variables can have names. Like x would be a name, or you could say x1. Let x1 be 3, and let x2 be 5. Okay, so the x1 and x3 they are variable names, right? The names of variables, and constants. They're all example of tokens, and these tokens, they can be described by regular expressions. Okay, and that's very useful for compiler writers. Not that many people do that nowadays. Well, there are always new computer languages being generated, and they will need, when that happens, somebody would have to write the compiler that translates that new human level computer language into machine code, zeros and ones, bit strings, right? Okay, so you can describe these tokens using regular expressions. So let's actually do an example, e.g. So let's say we're talking a constant. Now you may write in your high level code 0.125, right? And that string 0.125, that would be an example of a token, right? Because it's a constant. So to recognize that constant in your code, the compiler may make use of a regular expression. Now, here is a regular expression. Right? It's a mixture of symbols. Right? Like that'd be A's in an alphabet. In this case, we've got symbols from an alphabet of operators, the arithmetic operators, plus, minus, times, divide. Okay? And here's empty string. And now we're using pluses and stars. Okay? And D. What's this language? Well, it's a set of strings, and the strings here have length 1, and D for decimal. Okay? So these are the set of decimal digits, 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's D, the set. All right. Now some examples of strings that could be generated by this regular expression. Now this describes a language, right? So these examples would be members of that language. They would be decimal numbers, because that's what this is. That's what this thing generates or describes. Right. Here's some examples. 72. Now, why would that be? Well, there's no plus, there's no minus, and there's blank. So that would correspond to this one, the empty string here before the 7. And so this now the plus means that you have strings of at least length 1. Okay, so you must have one of these, and you've used it, so you got it twice. So you need that right? Oh, hold on. Sorry. Yeah, it's confusing. Look, I'll underline the unions. So that way you think of that as a unit, or that, or that. So you're unioning three things. It's confusing. I was looking on that as a unit, because that's what I'm used to. So, okay, so D plus. So any number of digits, as long as it's one or more. So 72 would be compatible with that one. And these two here, they involve decimal points. So we're talking about decimal pointed numbers. Now 3 point, what would that be? So there's no plus or minus, and no empty string, and you've got a 3. Where would that come from? Well, that could come from this. Wait a minute, here. Here. Yeah, this one here. So if we're using this one, so we must have at least one decimal number in front of the string, which we do. We have a 3, and then star, not plus. It gets a bit subtle, right? You got to be careful. I mean, if you're a compiler writer, you really have to pay attention to these details, right? And of course, you'll test your software later, and you'll realize there are bugs. And say, oh, I should have had a plus there instead of a star or something. Okay. Look, I'll circle them so it makes it easy to think about. Right. Okay, so 3 corresponds to that one. Yeah, you must have at least one decimal digit in front of the decimal point. You do. Yeah, just one, and then any number of. Yeah, you could have 0. You could have none here, which would correspond to this one. Yeah, decimal point and then nothing. Remember, any set contains the 0 set. Okay, so these would correspond to that. Now plus 7 point and then nothing after the decimal point. That would correspond to, well, the plus comes from here, right? And you're concatenating. So you could have a plus here, and then 7 point. So that would correspond to here. So one digit here would correspond to that decimal point, concatenated. And, implicitly there are little circles here and here. Okay, but it gets tedious, so you tend to drop them. Right, and this could include the 0, the empty string, okay, which is here. There's just nothing there. All right, now what about this one? So minus, so that would correspond to here, and then you've got a digit in front of the decimal point. So that would correspond to either of these. Hold on, let me check. I'm going to go to 0 here. I think that one's compatible with either of these. Does that make sense? Okay. Right now. Okay, so. These are examples of regular expressions in the context of decimal numbers. Now, so once you, if you're a compiler writer and you create these regular expressions, so you're applying the theory of regular expressions in the context of writing compilers, major application, okay, in computer science. Okay, so once you've decided the format, if you like, or the syntax as it's called, which letters, which symbols, which letters you use in your regular expression. So once you've decided on the syntax of your tokens, so this would be the token that corresponds regular expression that corresponds to decimal numbers. Okay. So once you've found the syntax of the tokens for your language, your programming language, and you can see this next line. So those tokens have been described by a regular expression. Okay. Then you can have software. There's several lines. I'll just go on in the next session. It's getting a bit dark. It's 4:30. Hope this comes out, and I'm not turning out on the light. This is an experiment.